AP Statistics. In this video, we are going to finish out example 4. We started example 4 in another video, but we hadn't learned some of the information yet. So we're going to pick up here on part H. The residual plot is shown on the right. Is the linear model appropriate? So this is feeding off of the idea of using the residual plot to determine if in fact the linear model is appropriate. So as you can see in my residual plot, I have a random scatter of points. There is no form to this. It doesn't make some kind of linear form, or it doesn't make a quadratic form or anything like that. So since I have a random scattering of points, my answer is yes. Okay, so yes, the linear model is appropriate. Because the residual plot has no form and is randomly scattered. You don't have to say no form. You can also say no pattern. Okay, so no form, no pattern, same thing. Alrighty, so that's how we can answer that question. So part I, the standard deviation of the residuals, is 5,740. Interpret this value in context. Okay, well, I told you in another video that your standard deviation of your residuals is the typical distance you typically see between your actual values and your predicted values. So the way we are going to interpret this is something like this. So the actual price of Ford F-150s, or of a Ford F-150, I'm losing it, is typically, sorry kids, I usually have this stuff written all out, but I didn't have it done. It's typically about $5,740 away from the predicted price. And you can see this if you look at your residual plot, okay? Because it's easier to look at it when it's their vertical distances, when this line is straight right here. So I want you to notice something. If you took all of these, right, and some of them are farther away and some of them are a much shorter distance from the line, but they typically are going to balance out to be about $5,740 worth of difference. So, and as you can see right here, see, this is very close to 0, but this one right here, that's like at 8,000. So that's what I'm talking about. So if you balance all of them together, it makes sense that the typical distance of all these points away from this line is about $5,740. Okay, so now we're going to talk about the coefficient of determination. Now, the coefficient of determination is r squared, and that is the same r I'm talking about for correlation. So further up here in the problem, you were given the correlation, if I can find it. Oh, maybe I didn't give you this in this problem. Really? What the heck, yo? Okay, whatever. So, well, I guess I'll interpret it on another problem. I can't remember where, but... Oh, I think I interpreted it. We did that on day 1. Sorry, kids. I know, I'm rambling. Don't judge. All right, so the coefficient of determination is your r squared. So that means your correlation squared. So what that means is this 0.66 here, that is actually, we use that as a percentage, and we're going to interpret it in context. So what it means is we can expect about 66% of the variability in price of Ford F-150s to be explained by the LSRL with X being miles driven. In other words, I can attribute whatever that cost of the Ford is going to be, I can attribute 66% of the reason it's that price to be directly linked to the relationship between the price and the miles driven. Now, the thing you need to remember when you're interpreting R squared is that if you just have the correlation R, you can find the coefficient of determination by squaring it, for real, okay? And let's say you're given R squared and you're asked to interpret the correlation. Well, you just take the square root of R squared to find R. But when we're interpreting this value, R squared, it tells me that I can expect whatever percentage this value is of the variability in price. So in the response variable is directly explained by the LSRL with whatever the X is, in this case, miles driven. Okay, now when you think about the variability in price, this just means that the price is being affected, 66% of the price in effect is being directly explained by miles driven. And if you'll think about it, if you've ever gone to a car dealership with your parents, or you've ever gone to a car dealership by yourself, and you've looked at cars, is miles driven the only thing you consider if you're looking for a used car? No, you're also looking at the age, or what it looks like, what kind of condition it's in. There are other factors that are going to determine what you're going to pay for that Ford F-150, but 66% of what you're going to pay is directly linked to how many miles are on the car. That's what this means.